Start record. I have no idea. I just restarted. It should be resumed. If there are two blocks later, we're gonna send you guys the two video links, right? Um, yeah, so I got a tire rocket. We just added the rock environment pack. We can click that at the end, so no rush to do that. The next will be flat portal, teleportation pad, that one. Add to project. And finally, the sci-fi mobile teleporter. There you go. That's a project. Cool. Um, it's teleporter. It's still downloading one of them. Just hold a second. Sci-fi mobile teleporter. I did click that, right? Oh yeah, it's here. Okay. Rock round pack, flat, sci-fi mobile flat portal, and oh yeah, I missed the cave rock, the material. We can use that for some things. Cave rock it's a material from formerly called Pixel Megascans project, which was acquired by Epic and made available for free to any Unreal project, which is really amazing. It's one of the largest material collections in the world. It's AGR, it's super high quality, definitely worth it, right? So just add it to project as well. And I just import all changes. Click in here, so it's gonna re-import whatever um, edits to make compatible, fully compatible with 5.7. There you go. We got our assets. So let's start populating things. So yeah, let's first get as a reference, let's get our toy rocket. And I'm just scrolling here. You usually want to go to static meshes, right? Where it's already assigned the material. The material is in here. If you want to make it more metallic, whatever. And the textures are in here, all of that pre-assigned to. So I just go and drag from static meshes the toy rockets into here. And like I said, if you drag things and drop them, it will snap to the nearest surface, right? So of course, if there's no surface, just gonna drop it in space. But if you point to a surface, it's gonna snap there, right? And yeah, like I told you guys, you see how just a single point line make things look pretty. It's just unreal magic. It's hard to explain to get that kind of fidelity in other engines, just very hard. You can't do it. It's not easy. So yeah, that's we use that size as a reference for what we're gonna do. And let's start creating our scenario considering this size of the spaceship with rocket. So for that, I'm going to be using some things from the rock environment pack. Let's move this up a little bit. And I have already pre-selected some of those. So just go here in meshes. And you can also filter from the name if you want, right? So you could do like SM underscore whatever. But right now, I want to select from the jungle rocks, and that'll be the flats. I'm going to be using the jungle rock 5. I just drop it roughly here so it snaps. Okay, so let's rotate it. If you have snap setting set here, let me use I think 45 should be good, or 15. 15. Be easy for you to get to 90 degrees perfectly. And I'm just orbiting around using alt left mouse button, and I move it down here. Let's start building our scenario and make this bigger. Move it down. And stretch it. Of course, you're gonna get strange when you stretch it, but there's a way to make it look much better, with just recreating the UVs. Of course, as you recreate UVs, you get, it edited in this object here. So you can duplicate it if you want, so that you get a separate um, rock, for instance, 8. And let me show you guys how that would work. Okay, that's roughly the size that I want. So it's okay. Okay, so let me just get rid of this. What we're going to be doing to get rid of the stretching is we're going to go to out of the selection mode. I go straight to modeling, the modeling mode here at the top left. And here you can do some things which are really interesting. In Xform, you can do the bake transform operation, which bakes it into the selected meshes. So if you don't want to alter the original asset, you can just, copy or drag the copy that you did here in the assets, and then you snap it to the same position and scale of the other asset that we're using. So one of the ways you can do that is by copy pasting location and scale, which is pretty easy, really. Here you can just select it, and if you go to the box where location is showing, instead of copying separate values and one by one, which take forever, you can either right click and select copy or use the super handy shortcut, which is shift right mouse button right at this position. Is going to blink at you like that. And then you copy that location, and then you select the other one and you shift left click. It just moves to the same position. Go back to the other guy, go to scale, shift right click, go to the other one, shift left click, and there you go. Same for rotation, shift right click here, shift left click. Or if you want to be really smart, you just make it a children, like a child, just drag it under Jungle Rock 5, and it's gonna literally inherit the location rotation scale from the parent. That's another way you can do that. So let me get rid of this guy. I don't want to add the original one. I'll be editing this dude here. So here in Xform, I click on Bake Transform, and it's alerting to you that's going to modify the selected static mesh assets. So I did make a copy in the content browser first. So I bake a transform, and now the scale, it's 1, right? But the texture is still stretched. But now that it's got this fixed scale, you can go to the UV settings here at the left, and then you can use one of the top options. Usually, Alt UV does a good work, UV Unwrap as well. They use different algorithms. Let's just play with UV Unwrap. It's going to give you a preview of what's going to try to do, and it shows like a grid. So you have an idea of the spacing, the sizing, etc. And you have some unwrap options. You can play with those, see what works best. I like XMap for this one. Auto rotations, built-in steps, etc., etc. So let me just click accept and let's see the result. You see how it's much better distributed now,
Wow.
right? Not perfect, but does a great job. And like I said, you can also use Auto UV. There are other options like um, use the UV Atlas technique or the X Atlas technique, and you can check for the density, so you can make it more dense, right? And then you check the result. And the material has options for tiling, which you can use to make the styling more intense. I'm not gonna spend too much time that. I'm just giving you guys a couple hints to make it look pretty real quick. Like even programmers have to know how to make things look pretty quickly. So there you go. We got our base, which we can just replicate for the ceiling. One thing I like to mention is about collisions, right? So let's get this dude here. You see there's a static mesh component, which is most early in Toy Rocket, something static mesh is here. right? So let me open it up. And here's the model itself, right? And the model, it's got it created its own collision shape by default, and you can see that by using the eye icon, selecting the show simple collision option, and you see that Unreal automatically calculated a very simple collision shape for it. So you want to review if it's according to your um, desire, right? Because I want to make sure that the base is flat. And in this case, it did a good job. But we're going to see next when we do the landing platform that the shape doesn't do as great a job, and at least not for our purposes. So we're going to be creating a new shape. But if you want, you can also set your own shape using the add box simplified collision. We're going to be seeing that in a second. Anyways, for us, this is good. This guy here, probably it's, I hope it's flat, but I don't know. So we can check for that. Let's just select it here. It's in, no, not you, the Jungle Rock. Jungle Rocks. Okay, the static mesh, Jungle Rock 8. Let me check how is the collision for this guy. We want to have it flat. Or we can just use the simple collision shape. Let's see what it gave us for free. Go here. You can use Alt C. It's the shortcut for the collision if there's any. Yeah, there's the collision. It's pretty flat. Actually, it's a flat plane at the top. It just chopped off here. So yeah, kind of like at an angle. That's good. Okay. If you don't like it, you just delete it and add a new one. Like I said here, just remove collision and add your own box simplified collision. Okay. Okay. I stick to it. I like it. I think it'll do a good job. So let's start. Let me just quickly finish this. Just move this to the left and duplicate this dude. Control D. You can also use the Alt drag arrow technique, which also works. And let's rotate this a little bit. No, that's too much. So you can either disable the snapping here for rotation, move, or scale, or you can lower the increment, right? So I'll leave it free form and do something like that. So yeah, now you guys are probably thinking, hey, that's a bit too dark. Maybe we should play with the light. I think it's a good idea. So let I have some coordinates that I have set here just to make things faster. So I just plug the numbers in. So 9 minus 25 and minus 35. Yeah, that worked fine. But yeah, you can rotate it manually and see what you get. This is a better option. Let me just move it away so it doesn't clutter the scene. Like I said, the position doesn't really matter as long as it's easy to select when you need it, but you can select it also from here. So yeah, let's add the walls to wrap this up. And we're gonna add the SM Mesa rock number 2 to the left. I just pop it on top of it to make movement a bit easier, and I drag it around here. Let me just collapse it. Might need to rotate it to make it look good or better. Won't look perfect. It's not the go here, right? Just to make it okay-ish. We're not doing a full-blown production game, believe it or not. We could, that'd be one. Okay, let me just increase this angle a little bit. I think this will be better. And let's add a corner here, move this over there. I want a corner with SM Jungle Rock 2. Yeah, that'll work as a nice corner. Notice that I'm still on local space coordinates. Okay. I do want to switch the materials, which is very simple, really. If you go to Instantials, it's a weird named folder. Within rocks, there are different color materials. I like this one the best for this kind of surface. Or we can use the advanced, where's that? Yeah, Megascans, medium materials. Yeah, this one. You can use that one as well. So you can just drag it and see the result. It's a material instance, so which means we can edit its properties like tiling. So I can just double click and yeah, let's see here, global, we can just enable tiling. And to see the result real time, you can just put it here. Whatever floating window you have, it'll always be in front of the rest. It's just a helper thing. In the beginning, it's kind of confusing, but with time, it starts making more sense. And just increase tiling. You can see that since it's an instance, you can see in real time the tiling getting more intense here. Okay. Or more detailed, as you want to call it. And something that I think is really cool is to be able to add some tint. Just enable base color tint and get a color which is closer to a reddish. So yeah, I want a different material, but different color, but not ridiculously different, just a little bit. And you can alter things like the specular. Just enable the parameter that you want to override, and then you play with it. So yeah, that'll make it a bit less intense to reflections, light reflections. Let me think I reduce saturation a little bit. There you go. Okay. Save and just apply the material instance to the other elements that you have in your scene. Okay, so finally we got the to the right SM, that's a rock. Choose rock half back, Mesa rocks, Mesa rock 3. Use that one here. Scale it up a little bit, shorten it like so. It's a bit better. I'm gonna move it to the back. All right. So guys, you're probably realizing that the scene is a bit too dark, right? Even with our light source, it doesn't look that great because it's a single light source. So you get a little bit of reflections and such, but it's definitely not looking awesome. So let's make it look better. For that, we're gonna do, let me save it first. We're gonna go to Window, Environmental Light Mixer. And actually, you should always, it's a bit of an exaggeration, but why not clicking all the 4 buttons at the top, right? Just start from Sky Atmosphere and you can create your own skylight. You see how you get a bit more, environment lighting. And then volumetric clouds. I rarely use those for just kind of like flat scene, but yeah, and hide fog. And that's going to fill in your scene and the lighting will look better. Okay. Um, one of the most interesting things is to play with the exponential height fog, where basically you can play with the fog density or lower it or increase it. But let's just make the fall off really big. It's going to make it really sharp here. You're going to see in a second why I'm doing that. Because I still want the black background. But if you disable any of those guys, you lose part of the effect that it's got in the light. Okay, so skylight, for instance, if I disable it, you lose the details in the shadows. So I don't want that. And even the volumetric clouds has a minor effect, not the most important one. So you can disable it if you want, but there's definitely some effect, some contribution. And our main directional light, of course, without it, nothing else really works. Okay, so which was the first light that we added. Um, You can play with its intensity here. So I don't know, let's try 2 looks, see what happens. And then you can get more intensity from the skylight, for instance. Intensity scale, right? And that's a lot. But you see how it gets more interesting as well. Okay, so this looking pretty good. Probably, I don't know, a bit lower, like 8 or 6 would look better. You don't want to get rid of the contrast, you just want to lower it so it gets a bit more pleasant to the eyes. So next thing is to get our background going. And like I said, you cannot disable those guys to make it look black, so we're gonna use a trick because that's what games are about, right? Smokes and mirrors. That's what we do as game makers. So let's add a mirror. No, just kidding. Just a plane here. So I'm gonna drag this guy. I'm gonna rotate it 90 degrees. Oh, let me re-enable snapping. That'll help me. Rotate it to 90 precisely. Then I'm gonna scale it. Actually, let me move it um, and move it behind the scenario. And just click R to scale it, make it really big. And curiously enough, there's some reflection from the white kicking in, but we don't want that, right? Let me just keep increasing that. Okay, and even though this is a default plane, we can go to rendering. I just use a rendering filter. So I can select the material here and I'm gonna use the black and light material, which is a default material included in Unreal. Just select, yeah, black and light material, and there you go. So you see how everything changed. So that's normal. Every time you add a new, especially a big element like a background plane, you're gonna have a totally different interaction of lights. But that's when you go back and start tweaking the ambient intensity again, intensity scale actually. So let's make that, I know 2 should be close to 1 or 1.5. Um, almost there, I think. Maybe just 1. No, it's too blown up. Maybe we lower directional light intensity to 1. Yeah, this is better. And then we go to sky atmosphere, no skylight, and set it a little bit more than 1. Let's try 1.5. Okay, up to the artist's taste. It's okay-ish for me. I do recommend for the skyline to have a bit of a color, especially because the texture is reddish. So getting a little bit of a blue shade is gonna help, in terms of contrast. Don't oversaturate a little bit, but get it just as, kind of like a post-process thing without actually resorting to post-process, which is interesting. I still think this material is good. I still think this material should get um, a little a little darker diffuse. We can keep playing with it. I think it's here, right? Yeah, that's the instance. So let me get back to booster level and let's try that with, I don't think specular is really the problem here. It's more like the base color tints. Yeah, just lower that a little bit and it should be good to go. Okay, because the diffuse does affect the reflection of colors. Let me save that. You don't need to compile materials, just save them. And yeah, you can also go to File, Save All. It's gonna save everything that's pending. All right, so here we got our scene setup. Let's click on play. Oh, the camera is definitely not well placed anymore. Let me fix that. Just click here, check on the miniature of the camera. Click F to reframe it. Move it back once again. Move it up. Zoom out a little bit more. About that. I'm gonna frame pretty much all of it. and uh, something like that. Okay, let's just hit play and see what happens. Okay, so far so good. It's looking fine. Let's there's still this. I think there was a cube that we forgot to delete. Just delete it, and I'm just add an obstacle. So the game's not actually it's pretty hard as it is, if you ask me, because there's no room for it to go up. So let me move back to global for both coordinates and pump this up. Move this over here. And I basically make it just a tad more um, vertical. Just scaling things up. I think I can just stretch that a little bit. Okay, it's more like a prototype, so no need to be super fancy in terms of placing things precisely. One thing that's useful in our game is to make sure that it sits flat on top of the surface. So instead of trying to make it, precisely fine in the position that it's not interpenetrating because physics doesn't like that, you just keep it hovering and click "and" on your keyboard, right? And then it just snaps using the collision shapes, right? So works just fine. Um, so we have another block here, and the center can use just the Mesa rock. Get that here from, could use a cliff rock, or I don't know, just take two Mesa rocks, or let's see if there's something good.
Pintar o cartão tem na cafeteria, que você parte? Por favor.
So I just get the, let's try this small rock here. I think it's gonna look okay, as long as we make it bigger. Oh, that's pretty big, huh? Yeah, maybe smaller, like so. Okay, let me make my own life easier, and just add try that one. Mhm. A little bit of an angle, and just place it in here. Local. Okay, it's a little bit of a ledge. So it's more of like an annoying obstacle than anything. It should make it pretty hard actually. Just lower that a little bit. All right. So let's change the material here to the materials master. Where are the root materials? Oh, potentials rocks. Let me assign this. Oh, not you. Here and here. Okay. Saving everything. And we're done with scenery. You can always check on the collisions, right? To see if it's making sense. Of course, this is a complex shape collider. You can simplify that if you want, using the technique that I've shown. One thing that's missing is the takeoff and landing pad. So let's do it real quick. Let's go to model teleporter, static meshes. This is the landing pad. Be roughly around here. Okay. Let's make it a little bigger. And the other is the flat portal teleportation pad. I use as a stakeoff marker or something. So I just move this over here and hit end and then push it back a little bit. Of course, you can always center using the that technique that I've shown you guys by copying, but it's not necessary. Okay, let's find a check on the scene. Looking good. All right. So probably just move the camera a little bit to the left, to the right, so I can see the right edge and move it up. Frames a little bit better. Good to go. All right, we got our game scene done. So now what do we need? Let me just save the collision thing. Here, collision. So now that we got our pieces in place, let's start giving it some logic. So first thing you need to do to convert your project to C++ is basically to create a C++ class. As soon as you do that, the the editor will do everything for you. But there are some steps I do recommend before you start, besides installing JetBrains Writer, of course. Um, yeah, so get JetBrains Writer, get it. But yeah, the first thing is go to your um, editor preferences. Mhm. And go to general. Here you have the source code section, right? If you don't remember, no problem. Just go to the top and click on settings and type source code. That's going to show here the source code editor option. By default, it's going to be Visual Studio, so just select one of the two options, Writer or Writer U project. So difference that Writer uses the solution extension, which is the default for Visual Studio, while Writer U project uses the actual project extension done created by Epic. So every time you create a project, you create a U project. And the solution is necessary, but when you're editing from within Writer using the U project, you have some advantages in terms of code completion, and it just works better for programming overall. But bear in mind that if you're developing for some platforms like iOS or Android, it might not be as compatible. Um, JetBrains and Epic are working on improving the support to your project, but if you're developing for PC or late gen consoles, it should work just fine. So we're gonna stick to it. Writer your project. It's gonna tell you that need to restart, so make sure you save all and then click on restart. So I hope so far so good. Be sure to make questions if you're curious about something. Let's check how's our time. Yeah, it's been already 1 hour and 40 minutes. Finally we get into C++. Takes some time, but we got there. Okay, let me open whatever you had open before. Okay, shut this down. Um, okay, project settings. All right. So first thing that we're going to do is to create a class, like I said, as soon as everything is wired up. So here at uh, at the top, you have this creation for blueprint classes. Okay, and you can in tools you have the option to create a new C++ class. And it's actually telling you that the code can only be compiled if you have Writer U project installed. Well, Actually, you need both. You need Visual Studio and Writer. So don't take that for granted. You can't just have Writer. If you're on the Mac, you need both Writer and Xcode installed. So click New C++ class. And what we're going to be creating is actually an actor, because an actor, it's an object that can be placed or spawned in the world. It's a game object, basically. So just click Next. And here's where it's going to place it. And one important element in C++ for Unreal Engine is that you always have the header files as public, and you have the source files as private, right? That's by definition. So just give it a name. It'll be just Rocket and create the class. And as you can see, it's going to create the header and a C++. The header is basically the definition if you're coming from other language. It's it's a bit like an interface in a sense. Um, it's not the same thing, but it's pretty close, where you have just the declarations of the properties and or variables and functions or methods, right? And here's where you have the implementation or the actual logic, the code for it. You can have minimal, really thin layer of logic in the header, like you do with properties in C++, in C Sharp, sorry, we're just checking for what's the value type of the format, whatever, but don't try to do much. That's the gist of it. So I'm just creating a class. And you see that as I add code to the project, it's gonna actually convert the project from blueprint only to blueprint slash C++. And it's letting you know that it now includes the sources. Please close the editor and build from your IDE. That's a very important piece of information. Now we need to build our project from the IDE. Cool. Just hit OK. Add must recompile. I'm adding the code now. Yeah, can do that. Writer project loaded. It's going to load that. I will close Unreal Editor. It's going to ask you to trust an open solution. Do it. And I'm just gonna say, this Windows, so it takes over whatever it was there before. And there you go, our first C++ class. Don't ever let it scare you. Like, lots of it is boilerplate, and I will go slowly through each step so it makes sense to you guys. So, like I said, here is everything that you have access to in your program. Let me quickly describe to you. I think this doesn't seem to be connected. So oh yeah, it's already connecting to Rio because I was missing the icon there at the top. So it's telling you that writer link plugins recommended. It is true. So usually do you install it in Engine and in the project? I like to do both just to be redundant. Let me try just install the plugin in game. So it makes a better bridge for code completion and shows if, for instance, there's any derived class from this class, if there's anything in the game overriding a parameter or a property, for instance. There are many cool uses for that. So I'm compiling writer link to the project. You could do that to the engine as well. It takes a little bit of time to set this up the first time, but the cool thing is that after we get this going, we can literally compile using patches, which is basically what Unreal calls, Epic calls a live compilation, right? So it's really, really fast. Of course, if you're editing, I don't know, 20, 30 files at once and getting back to Unreal, it's going to take a little bit more time. But if you're just tweaking things, which is what we commonly do, right? We just keep tweaking things. Oh, let's try this, that. It takes just a couple of seconds to bring your changes to make it live inside your project, which is really awesome. So yeah, I think it finished. No, it's still doing a thing. Let's wait a little bit more. That's not what I wanted. Okay, writer link plugin installed. It's not needed anymore to go to Unreal and enable the writer plugin. If you're past 5.6, it's already default, right? But if you're on an older version, for some reason, you have to go to plugins in the editor options, and then you search for writer and make sure the plugin is active, okay? Yeah, so let's go through this guy here first. What's this pragma once? It's basically a way for C++ to prevent you to include a library more than once, which would just bloat your code. So it's a safeguard for inheritance. Okay, so it's basically whatever is defined here is going to be defined just once, regardless of if you're including a library. For instance, I'm including library B, which uses library A, and I'm including library C, which also uses library A. Library A will only be included once, right? And shared by both includes. So here's basically what you need for your code to work with any. That's Unreal Engine core, pretty much. That's for the actor. And that's one include that you cannot miss. It's basically an automatically generated include for the specific class inside the Unreal project. This include is important because it always has to be the last one in the list. So we can add sound, magnet particles, whatever, but whatever we include should be before that last line. So it's usually a common, and that's a good hint. It's a common thing to just add a space here so that you always remember, not a space, an empty line. So always remember to add your other includes before this guy because this has to be the last one or else you get an error. So U class. By default, it's not a blueprintable class. This is a macro because honestly, that's what the real class is. This thing here at the top, it's a macro. What's a macro? It's a way that C++ has to replace a tag with a declaration or a function. It's really powerful. In many other languages, macros are like Lua, for instance. If I recall correctly, you can only use macros to replace identifiers, right? But not really functions. For functions, you have to do something else. But here you can use for both identifiers and functions. So in this case, if you hold Control and click here, it's going to show you the definition, but it's super scary. I won't show you guys. But it's basically a way for you to tag whatever class is defined after it to tag that this class is usable by Unreal Engine, right? So if you consider that this is mandatory, this is mandatory, this is mandatory, this is optional, but it might break your project if you're not careful. So basically, the main difference is whatever it's self-generated here, which is mandatory, like I said, and whatever include defines the type um, of the class that you're defining. In this case, it's an actor. It could be a pawn. It could be a character, right? It could be many things, and that would change the includes here at the top. So here's what actually defines the class. So the first part of it, you can touch it, another macro. So let's see how much boilerplate code we have, right? So that's why sometimes the scripts get a bit scary, the C++ scripts get scary, not just because the language sometimes it's a bit, stiff and has lots of acronyms and symbols to make it kind of faster to type, but also because, especially for Unreal Engine, the API is very macro intensive. But anyways, if you just start blinding your eyes towards those things, which honestly you can't touch this, you can't touch that, uh, it starts becoming much simpler because now you know that this is just a constructor. You can't touch it. It has to have the same name of the um, a rocket. The name of the class can't be changed as well. It inherits from actor, and this is just the uh, a predefined prefix from Epic. So every time you get an actor, it has to start with a capital A. And for multiple symbols like a vector or color, you start with an F. I'm not even sure why it's F, it just is. So there's just a convention that you quickly get used to. There are many documentation links, and we go in depth in our course, of course. But anyways, you can see that here we have begin play, and here we have the tick, which is the very same thing we saw in the blueprints, right? The begin play and the tick event. So if you just ignore everything else, that's the guys that we will be playing with, okay? But not the implementation. This is just the definition. The implementation goes in here in Rocket CVP, and it shares the very same name. So in the constructor, it just assigned some presets. For instance, this makes sure that the tick event is running every frame. When would you not use it? When you're not using tick. So, if you tailor your class correctly, it will just require events and not ever need to use a tick, right? Which is great because ticks are expensive. When you're working on performance and optimization, you have to watch out for those, right? But in this case, let's do it the simple way, and we will have tick and we will have begin play to set some things up. So the logic goes in here. Whatever variables we need will be set up here. Cool. So what exactly do we need? Um, Actually, there's some things that we'll be doing back and forth, right? So any game development in a real engine, if you're doing it the most effective possible way, will take part of your work will be in the editor and the real engine editor, and part of the work will be here in the code or in the blueprints, depending on what you do, right? So there's no, oh, I sit down here and write and program everything top to bottom. No, you'll be going back and forth for best effectiveness. So first things first, let's go to, let's see, um, let's start from the variables. Yeah, variables in the header definitions. It's a good thing. So let's go after the public section. Let's see if we need something. Not really, the constructor is fine, but we will be needing some properties here. Okay. I don't need to install the mesh. Okay, so what we want to do, we want an object which can instantiate the mesh or has it assignable in the editor. I'm going to be showing that both ways. So how do we get a static mesh? Static mesh, as you guys saw, is just a mesh in the editor. You can do the include first or do the declaration of the variable and then do the include later. Up to you. Just can't skip any of those two steps because we still don't have the static mesh variable type defined here in the code. So let's start from that. So it'll be a use static mesh component. And of course, you have really good code completion, which you can just hit tab to use. But it is correct. I just call it Rocket Mesh instead of static mesh. Oops, Rocket. And why is that a pointer? Because there's an asterisk here at the bottom, which means it's a pointer. Uh, a pointer is literally what the name states. It's a data structure which points to something else, another variable, another data structure. In practice, an address in memory, which will be unboxed or converted to this type once it's brought back. The trick is if you're using something that already exists, right? Either previously created or already exists in the editor, which is the mesh component for the rocket, you should be using a pointer. You're not creating it from scratch, correct? So that's why we're using a pointer. And um, it's complaining that can be destroyed because the rocket mesh is not declared in the well, it's actually in the header, but it's not saved yet. So one thing that's really important is to make sure that you have the right type that you're creating. So here it'll be, let's just add an include for components, and that'll be the static mesh component H. Okay. Sorry for the noise. Guys here are really making noise today. The dog and then the kid and whatever. So, and here we have our reference for, we will set a reference in this object. The problem is that it's not being stored, right? It's just a variable in the C++ space. It's not keeping the reference that you assign in the editor. So it's just a flaky variable right now, very, very flimsy. So we want to make it um, fully compatible with the editor. That's our goal. And for that, we use, guess what? A macro. And our macro here will be uProperty. And you see, there's a suggestion there. I won't care much about it, but definitely has to be a new property. And there are some options. One of those is if you want it to be just view only, you set it to visible anywhere. This guy here. And there's now a suggestion to make it blueprint read write, but it could be also blueprint read only, right? And you can also assign categories for it. So it's better grouped in the editor. We'll do that next. But that's what you do before the declaration of the variable. You basically say the type of the property in Unreal Engine's editor. So this is visible anywhere, blueprint read only. So this is just read only. It won't be assignable because, well, we're going to do it the hard way and just create the rocket mesh ourselves, which is a terrible idea, but some people keep asking how to do that. So yeah, let's check here. Well, this we can already compile it. So is the editor open? I don't think so. Nope, it's not open. So let's just build it, clicking on the top button here. I built it the first time, so that's the first time you build it. It's good to make a full build. After that, we enable the live compilation. Hmm. This one is lower, of course. You'll get to the fast part in a second. That one spins up your fan or your fans, depending on how many fans you have in your computer. Usually we have a bunch, right? As soon as it does that, it's going to be updating the project uh, with the structure that it just did. You see that it took like more than a minute, which is a pretty long time. But yeah, just let's just click on run. It's gonna be actually launching the editor with the just compiled project. Like I said, it's a good idea to do that the first time at least, and do that with the editor closed. Almost there, still loading. Thank you, Elson. Hope you enjoyed the rest of the lesson if you enjoyed it so far. Thank you for hopping by. Okay, where's the editor now? Booster. Yes, here. Okay. So now that we get it compiled, you'll be shown it. It'll be seen here within Booster. You see Rocket C++ class. Um, you can even drag it here, right? And it's going to be showing you as an instance of the class because it's an actor, right? If it inherits from actor, it can be placed in the scene already. So what we have right now is the property that we defined, rocket mesh, and literally non-assigned, but I can't change it because it's set to, like I said, read only. So if you want to edit that, you first have to make it not just visible, it has to be added anywhere. And instead of read only, it'll be read write, correct? Oh, and that's a very important part. Now that we get it compiled the first time, and we ran the editor from writer, that's an important step too. Sorry if I didn't stress that out enough. You can use the live compilation using this really cool button here, right next to the alert that it didn't save everything. So it just save it first, level, and click on this guy. Here we go. So here's the live coding window. And you see, just in a few seconds, it um, already updated my code in the project. So that's because it just does a patch, right? It doesn't recompile everything, just whatever lines you changes. Super smart system. So now you can either go here in Rocket Mesh and select it, or you can go, which is probably a much smarter idea, select it in here, the static mesh, and assign it in the Rocket Mesh. Oh, it ain't got the full-blown editor option, so let me go from here. I think it's set to class actually, and not to an instance. Yeah, I think I didn't. Let me see. Static mesh component. Oh, no, it's not the component that we want. We want the actual static mesh. Let's see. Static. Should be, yeah, not box component. It's static mesh. Let's see if it's required. We'll be using we might need the component layer. That's when you're adding things manually, which is the other option that I'm going to be showing. But yeah, let's see if just using the static mesh. I believe it's the default one. So just save, come back and do live compilation, see if I get an error or not. It's at succeed. Okay, and I get the full-blown um, static mesh selection here. So select this guy and click here. There you go. We got the rocket mesh defined. Of course, that's not actually creating the static mesh component, which you can, of course, manually come in here and add a component. What's a component? It's actually a piece of functionality that you add to your actor in this case, right? So the piece of functionality that we want is actually a children mesh, which is a static mesh. So just search for static mesh and um, it's going to be assigning this static mesh, or you can do that through code. Both will work. You can see that now you get a visible display of the rockets. Okay. So, but like I said, that's not good enough. We want to make sure we can have this assigned and instantiate that. Before we move on, I want to do something really important. I don't want it as a static element in our scene. I want it as a blueprint so that we can more easily edit its properties. And don't think about blueprints just like a flow graph. We won't be using functionality. We just need it as a uh, something that we can easily replicate, right? That's why I'm turning that into blueprint. Unfortunately, the name blueprint became a synonym of logic done with nodes, but that's not true. Like I've shown you guys, there are blueprints with no flow graph whatsoever. And you can even have the flow graph but not use it, or just use it for begin play, which is pretty fine. No problem at all. Um, we want to use C++ where it makes sense to give us more performance, or when dealing with physics, when dealing with arrays of multiple objects, right? Those would be interesting conditions, or just when you're doing multiple loops or multiple mathematical operations. That's not a great thing to do in blueprints. It's first, it's awkward. Even an addition takes 3 nodes just to add 2 elements, when you can just type A plus B assigned to whatever in C++, so much faster, right? So that's the kind of thing that you have to consider when selecting what should be in blueprints, what should be in C++. So what I really want to do is, let me delete this guy. What I really want to do is get the class here, and I will create a blueprint class based on it. I can do the same by right-clicking or creating a blueprint here, right? And creating a new blueprint class, searching for my rocket class, right? That's the same. I can do it from here, or I can come in here and right click, create blueprint class based on rocket. It's gonna ask me where I want to save it. Because I can't save it in here, like I told you guys, it's not within content. So I just select here blueprints, and then name will be BP rocket. Okay, create rocket class. There you go. And here's our BP rocket, which has the very same parameters we have in our code. Right now it's just rocket mesh, but we're going to be adding more, of course. And so let's keep adding things. For instance, I will add in the header, I will add B input allowed, a boolean, which is on true or false, right? B input allowed, I make it true because eventually we want to interrupt input when we crash our ship, right? I'll need the thrust force, so we can actually add some force to our rocket. And from my calculations, because the basic unit in Unreal is like centimeters, it's very small, you have to really push the physical forces up. And one little trick here is when you're setting a float, the default notation is it always requires an F. If you don't do that, that's a double, right? So you might get some errors or even precision errors. So always add an F. And a quick tip is to remove, if you don't need it, the 0 before the F, and that works just fine. This is not accepted by the compiler for some reason. I do believe in C# you can do that, but not in C++. But just the period, just the point does work. So you don't need to do the 0, right? And we're also going to need a rotation force. It's going to be, I think in my class, 5,000 worked fine. So just like we did for Rocket Mesh, we have to add the U properties for everything. So that's a trick that works for me. Not sure if you guys will want to use it or not, but personally, I think this gets really messy really quick. I think, at least for me, right? I don't know if everyone's like me, but I have a hard time seeing the variable types and the values amidst all those new property entries. It gets, I don't know, confusing. So what I do is I add 9 tabs before the U property settings. Like I said, not everyone will like it, but it's something that I feel it's useful for me at least. So I just type it 9 times. I can even copy it and just do it at the beginning. Oops, not here. Sorry. Here's just one. Here and here. Because this way you can just literally browse through, literally browse through the variables, and you see the type, you see the name of the variable, you see what's the starting values. And if you want to check if it's read write or read only. If it's visible anywhere or edit anywhere, you just look at the top right and it's like a comment, right? But it's needed. It just has to be at the line immediately above the variable. So it's no problem if you just indent it a lot. So this works for me. Just a little tip. Another tip is that we're going to have some private, at least one private element, which is a function, a method, since it's a class, which is only required internally. So I do it, I set the private section here at the bottom. And one thing that's here is that if you define it here anywhere before the public section or sections, it's by default, it's private. Okay, that's a C++ thing. So I could simply not add it here, just add it at the top. That works. But I will need um, apply rotation in the header. So let me just add it here. Like we'll return nothing. It'll apply rotation, taking delta rotation. Yeah, that's enough. And it's not implemented, of course, not implemented because I didn't add it to my CPP. So for functions, like that, it really has to be implemented, a bit like an interface in other languages. So here's the same. You right click, you can show the context actions or hit Alt Enter, and then it generate a definition in Rocket CPP, and there you go. You get the apply rotation declaration here. So here you get it in the header and it's private. And like I said, it could just be not within private, it could just be here, right? And that's the very same. It's a bit more confusing, I think. I like it um, within the explicit private section at the bottom. And something else is, as you can see, you can have multiple blocks for the same visibility, right? So here it's public, and you got public again. So here you get the constructor, and here you have the properties, right? So you can split that or move them together. That's up to you, right? You're not obliged to put everything in a single block. Another little trick to make your code easier to read. Okay, so with that, we got everything we need in terms of the header, and we have to start implementing things, right? So let's see what's missing, if anything. I don't think we're missing anything. I think we got it all. Hmm. So let me just organize my panels here to bits. Crazy. Okay, so in the constructor, let's create a component, right? Instead of editing the blueprint. Both options would work just fine. I just want to show you guys how to create the component without requiring you to create it here manually, but feel free to just create it manually using add and just assigning the static mesh. It'll be the same. But sometimes it's good to have a predefined structure of components from the code. And that's a really good way to use C++ and leverage its power into the blueprints world. Okay, even if you're gonna code most everything in blueprints. And that's a very, very simple thing to do. So let's get a rocket mesh, which is a use static mesh, and I create, actually should be thinking of it. If you don't have a reference, it should be a component. So let me just add a component here. Use static mesh, rocket mesh, mesh components, rocket mesh components. This is yeah, I forgot the view property. And I'm pretty sure this has to be visible anywhere. And blueprints read only. If you're in doubt, remember you can just delete things and hit comma, and it's gonna show, some options And you can also, in the comma, you can hover, especially in parameter. I think in macros, not very easy, but you get some comments like what does visible anywhere means, etc. I think in your property, you can, yeah, you can hover over your property itself, and it gives you some hints about what it is and what it can take. All right, so that's the rocket mesh component, and that's the rocket mesh. Okay. Why did I do that? Because I need both. So if I go now and I say rocket mesh components, which I'm going to be creating manually, I'm going to create a default sub-object, sub-object. And that'll take a generics for its type, which would be a use static mesh component. And it's going to take as a parameter the name of the asset. By default, it takes a text. So there's three ways that um, Unreal Engine deals with strings. I think it's worth a quick pause just to explain that. One is fname, the other is ftext, and the other is fstring. They all seem like the same, I know. But the thing with fname is that they're immutable. So those two guys are immutable, which means they're like constants. They will not change throughout the execution, right? Um, but ftext accepts localization. So ftext is localizable, which means it's very simple to replace an ftext defined string by another language like German, Korean even, or any other language really. So it's easy to localize ftext. So whatever faces the user, like UI messages, which the player is going to be seeing, you're going to be using ftext. If it's something internal, you'll be using um, fname, right? And fstring, it's basically dynamic and mutable. Dynamic, mutable. Right? So, which means it can be changed throughout the execution of the game, and it's commonly used for elements which will change during the execution of your logic, right? So it's mutable and it's dynamic. So that's when you're going to be using f-string. So if you ask me, create a full C object could take f-name because it's immutable. I don't see the advantage of having it localizable, honestly, but by default, it's what it takes. So I don't make the rules again. So let's just do what it expects, which is a macro to convert to get a text from a string, a regular C++ string. So just, just type text and whatever is in there. And it'll be basically the name of the component. It's not the asset, right? No, it's just the name that the component will show when it's added automatically. So I just call that rocket match query. That's good. So, and let's make that the root component. So it overrides the scene root. So just that's a reserved keyword root component. So that's why I don't need to create anything to refer to it. And I just type rocket mesh here. Actually, a rocket mesh component, sorry. Component. And that'll basically replace this guy here, the default scene root, which is something used to place your assets relatively to the root level of it, or the position of the actor to be more accurate. Fine, so we created the component. Okay, so whenever, let me just do the live compilation, save it, back here, live compilation. There you go, successful. And yeah, when we select, oh, by the way, I think I'm still with the static mesh actor. Let's make sure we replace that with one instance of our blueprint class. So let me just instantiate that. And you see that it created our rocket mesh component. It's just not assigned to anything yet, right? but it's there. And I'm still not gonna replace it in here just because you don't have the mesh, so I want to be sure what I'm doing. But let's assign the mesh. So um, yeah, two things that I could do is the right way, which is basically getting this property here from the actor, which out, not in root, not the mesh component, the actor. So go to the root and then select the static mesh. I think it's not assigned here, so let's just go to toy, rocket, yada yada. So that's just a variable, remember, a variable created in our C++ class. I'm not actually doing much with it just yet, but it's in the blueprint class, right? So as I drag it here, it's using the static mesh to, let me just make sure I'm fitting the right object, the rocket mesh component. So that's one way to do it, okay? Which is the one that I recommend, honestly. But there's another way where you don't really want to do that using the blueprint editor. Just get rid of you, save all. Let me just clear this field. I'll save and get rid of it. And let's do that. So the the other way is literally to get a reference um, and plug it in, right? So let me do it for you guys to see how we do that. I did create the default sub-object, but I didn't set the static mesh, right? Which could lead to issues. Like by default in Real Engine, I did it for me, but it's good to make it explicitly. So to make that explicitly, you would just call a method within the component, which is rocket mesh component, and then use an arrow. Why do you use an arrow? Because this guy is a pointer. So in other languages, you'd use a point, but this guy is a pointer. So if it's a pointer and you want to call a method in it, you do not use a point, use an arrow. That's by default. Actually, that's a shortcut for a more ugly format, which is basically um, casting from the pointer, right? And then after you get the value of the pointer in parentheses, then you call the point. But it's called dereferencing. But it's just ugly. I'm gonna show you guys basically that you do a dereference and then like so. So you do reference and then you get the property. So this asterisk in the front is basically get the value from the pointer, the value that the pointer is pointing to, and then you call the point. But it looks ugly. So they just created the arrow operator to do that for you, right? So yeah, whenever the element is a pointer, do not use a point. Sounds weird, right? Whenever it's a pointer, do not use a point. Yeah, use an arrow. Okay, so and that's where you do the static mesh. And what you pass on is basically the use static mesh, which we already have, which is the rocket mesh. And that's it. You just assigned it programmatically, right? So watch out because that's in the constructor, which is actually called as soon as you drag it onto the scene. So if rocket mesh is not assigned, you're going to get an error, which C++ is very hairy, right? It might crash your real editor. So yeah, whenever you do this kind of thing, make sure you have the thing that you're trying to assign to. So I would do something like if rocket mesh then assign it. Okay, that's the same thing as checking if it's not no a no pointer because it's a no, right? So no PTR is a no pointer. So if it's not a no pointer, it means it's assigned, and then you can assign it. All right, that's one way to do it. I'm using Control Alt slash to comment that out. And the other way is the more it's the longer one, but it starts the very same way, but you actually use something called a constructor helper helpers. And within construction helpers, use the object finder, F object finder. And here you pass in the class, which is a use static mesh. And finally, you pass the text like it's recommended here. And oh, that's not all actually. You pass on the text, and whatever you recover, you have to then cast it to an object. So it's a pretty long-winded way to get something, but let me do that for you guys to know it. Objects. Yeah, I think that should be within the parentheses. Too many parentheses. Let me wrap up the text first, and then I wrap this on. I think this is static mesh, text.object, and we have another parenthesis here. Okay, that's it. And what goes in text? Is that an identifier? No, that's where you pass on the entire reference, which is the internal path to the mesh. So yeah, it is very ugly. I don't recommend doing that. I'm just showing it because people keep asking, oh, how would I do it totally programmatically? There you go. But don't do it. So yeah, find the static mesh they want to use. Right click and search for copy reference. Just Control C will do it. And here you can see how long it is the reference path to the actual object. So copy the reference, go in here and paste it there. I usually break the line so it's not as terrible, like it's just terrible. Look at that. Oh my God, so big. Oh, I forgot to add the the quotes. Let me just add the double column first and then double. Uh, yeah, this will do. Okay. And that object, so it's cast to an object. I know it's terrible, but that's how I do it. Totally programmatically. No drag and drop involved. Just lots of gray hairs added to your head. But and another problem is if you move the static mesh elsewhere, you're done. You're lost. This will break badly. But supposing I didn't screw up anything, it should work. Let's see. Let me get the blueprint from it. And just as a reminder, here we no longer have the static mesh defined, but you see how in the miniature it's still there. Let me drag it and see what happens. Nope, didn't find it for some reason. Let's see, rocket mesh components. Um, I'm not sure, like the miniature showed it, but it's not finding there. Oh, static mesh not defined. Yeah, because I'm copying it from the static mesh definition. Or did I assign to rocket mesh? No, I don't need the no, the rocket mesh component is being created, and then I said static mesh from this here. Yeah, this should work. Let's see what happens. Hmm. I think live compilation is giving me trouble. So let me just, I can run it again from the editor or just do what I'm going to do. Just save all and run it again. You can run it from here if you prefer. This is writer link settings. Just build it. It'll take a little bit. Second time, 5:30. We're heading um, to the end of our session. I'm still going to add the boosting thing and the physics. So we get the proper skeleton of our game working. We won't be able to shape it up to perfection, of course, but yeah, enough to get us going. And definitely, if you're interested, just get in contact with the Vertex School group, and I'd be very happy to have you guys as students. And yeah, we have a bit of time for questions if you want to make it. It's game developer program is a 9-month um, course. which is definitely graduation level. I have lectured on universities for more than 10 years. So yeah, the largest game development course here in Brazil. I was a proud teacher there for a pretty good time. So let me open it manually. I don't think it opened for me for some reason. But yeah, feel free to check on our conditions. And if you're interested, it will be a great pleasure to have you guys with us and dive much further in terms of adding sound effects, adding particles, and all the bells and whistles that you can do in the game. Oh, look at that. You see, BP Rocket now, it worked. So it's just live compilation. It's not perfect. Sometimes it just breaks, especially when you're trying to do this kind of hairy thing, which with resource helpers. But it's good to know how to set things up manually. That's one of the tips that I wanted to share with you guys. But honestly, it's not the best way to do it. Well, so this element here, which is an instance assigned to B Rocket, is connected to the C++ class, everything the way we wanted. I'm just gonna snap to this position. So go to General, um, Shift right click, add this one, Shift left click, and let's get rid of the previous. Um, where is that guy? This one. So delete it. And now we just have the actor. We can move it up. Let's check our physics. Let's simulate the physics so it actually, drops, takes the effect of the gravity. I set its mass to 200. In my test, that worked well, and enable gravity is enabled. Initially, I won't set anything up. I just want to play with it real quick. Here it goes. Collided, bounced it, and yeah, laid in place. Awesome. So we get it alive. Um, I do recommend doing this kind of thing, not in the instance, but in the blueprint. But if you want to play here because, it's a bit more interactive, you're not going back and forth and stuff, you have the option to apply any instance changes to the blueprint. Just click this small blueprint icon, drop down, and select apply instance changes to blueprint. And whatever you changed here, you're going to be seeing there. Notice that it revert to data only blueprint, which we probably want one. Let me think. Yeah, we want one because you want to add the particle emitter. We won't be doing that today, not enough time, but as you want to add Niagara particles for the thruster to be turned on and off as you hold spacebar, it's what you would need to get the full blueprint editor so that you can go to viewport and do your things here. Okay, and add our elements, etc. But you can see here in physics, I just filter at the top physics, you can see how the changes that we did in the instances are now recorded in the blueprint, right? So now that we have all this in place, we can literally start doing the fun part, which is making sure we can add impulse to our rocket, which will be done here in tick every frame. Okay. So never added the super calls because super calls basically make sure that the ticking system works. It's just something running in the super class or the parent class where this actor class was inherited from. So yeah, you cannot delete this guy. But after it, you can do whatever else you want. So first thing, if the input allowed is false, that's why I get exclamation mark at the front of it. Just get out of it. I do recommend getting returns. Oh, I got a problem with my shortcuts. Happens sometime. Let me just fix it real quick. United States, international. Cool. Back to here. Yeah, I always recommend having returns on separate lines So it's easy for you when you're browsing through your code to figure out the return points because return points are super critical. It tells you when the code is not proceeding further. Okay, so always make sure you have your returns in highlight. Um, so if input is not allowed, it won't do anything. We want to get the player controller like we did using the node in the blueprints. Here, you would do first assign the type. It's a player controller. Since, again, the player controller already exists and it inherits from actor. So it starts with a player controller, finishes with an asterisk because it already exists. So you're using a pointer. That's the logic. You're always going to be using the same logic. I call it PC, could be whatever else. And then I get it from the world because the player controllers are global references. And global references, usually you're going to get them from the world. And this is a pointer. Doesn't look like it, but it is a pointer. If you hover, you see that it's UWorld asterisk. If it's a pointer and you want to call a method in it, you use an arrow. So arrow get first player controllers, the first option, actually, very simple. And now I got a handle for the actual player controller and this variable PC. And if it was not found for whatever reason, I want to get out of it. So that's a very common pattern where you basically test for everything uh, that are like exit conditions. It's called reverse if. There's one of the names we use in programming for this kind of logic. But the trick is to whatever's going to get out of what's going to be executed every frame, you put it at the top of the logic, right? That's going to shortcut the exit. You're basically exiting if input is not allowed. You're exiting if there's no player controller, or couldn't find for whatever reason the player controller it doesn't do anything else. So you're saving up cycles and optimizing your game. Um, but what you want to do now that you know that PC exists, the player controller exists, is you want to check if a certain key is down. So you go, is input key down? And for a key, you could use, um, it's an F key, right? It's waiting for a constant. But these specific constants, it's in the E keys namespace. So namespaces, they take two columns like that. So you do E keys, double column, and then in this case, spacebar. With capital B, that's the good thing with using writer, it won't let you make mistakes, right? Yeah, just hit tab and it fixes it for you. So if spacebar was or is being held because input key down is basically while the key is being pushed. So I won't do being put allowed. That doesn't make sense. So sometimes the suggestions are just terrible. That's what AI does to you. So you can disable suggestions if you want. Just go here, settings, and disable it. But yeah, what we're actually going to do is we're going to get the up vector because we're going to be adding force to the up vector pointing up, which depends on the rotation, right? So that'll be an F vector. And it's not a pointer, it's just a value. So there's no asterisk there. And we're going to call it a vector. And this will be from the actor. Since it's from the actor, I don't need, again, any external reference. It's referencing self, right? But you don't need to type self, arrow, get, whatever, because that's implicit in C++, and then many other C-based languages as well. So what we're going to do is going to get the actor vector. Right? So no need to do this, right? It's not an error, it's just redundant. I think it's this or self, I can't remember. Yeah, it's not an error, it's just redundant. Okay, so don't do it if you don't need to. And I will add to my actor, to my mesh, which is, I think it's rocket mesh, not the component. I'm going to be adding a force to it. So again, that's a pointer, use an arrow, add force. And here's the type of force. I think it has to be the actor component because the mesh will not take a force. It has to be the actor. We can just do that force straight. Let's see if it works. Yeah, this is the force type. So yeah, probably the component will be required. Okay, mesh components. Yeah, force, yeah. And we need the mesh component there. So we have the force, and the force will basically take the it takes an f vector which has x, y, and z. So you could create a new f vector if you want. And here you would basically assign the z because it's up. So it would be 0, y, 0, and then a vector. Um, not a vector. Now we need the thrust force, which is the variable we created before, right? Then thrust force. That's one way you could do. Or the problem with that is that it will always point up. It won't take the local rotation, right? So if that's what your game asks for, supposing it's a jumping game, so regardless of where it's pointing to, you want it to move up in the whole coordinate system. That would be the way to do it. But since we want to add the force pointing to the up vector, sorry, what you do is you multiply the up vector by the thrust force. So just get the up vector that we just read, multiplied by thrust force. That's it. Because supposing that's the up vector, right? My rocket is pointing in that direction because I have been rotating it. Look at that nice rocket. So what you do is basically you're gonna get this vector and add a force in that direction. That's because the gameplay is a bit like asteroids. I believe you guys have already played that. So, and that'll be the length of it, considering it's this length is 1. The length of it will be multiplied by the thrust force, so it becomes, more intense, more force, really. So that's how you make it move. So let's save that and um, do live compilation. Okay. And let's see if it responds. Oh, there's something really important. Our blueprint instance, it has to take input. So go to general because you don't have a pawn and actually all and select input and make sure input allowed is enabled and auto receive input has to be enabled for player 0, right? Because that's what it's taking input to. The pawn class will automatically have the set, but actors will not because actors by default are not controlled by the player. But in our case, we have to explicitly state, oh, I want this actor to take the input from the player. Okay, so that's how you do it. Make sure to select the group there. And let's see. So as I hit spacebar, I start pushing up my rocket. Oh, it works. And of course, I can destroy everything and it can just go out of the plane. So to make sure it doesn't go out of the plane and just sticks to this 2D plane, because this is like a 2.5D game, right? The gameplay at least. And what you do is you go to BP Rocket. Again, you can do that on code, but again, it's just settings. If it's just settings, why would I do that on code? If I'm creating a template, like I've shown you guys, that's fine. Do it in the constructor. But if all I want is to specify some parameters that I might want to add during design time, it's a bad idea to have that in the C++ class. Okay, so let's just tweak it here. And again, in physics, I already have the filter for it. You're going to see the constraints. And for position, I just wanted to move I don't want it to move along Y, which is depth considering the screen, the viewpoint. I want it to move along X and along Z, so this will be locked. So it never goes further away from the camera plane. And for lock rotation, it would be the opposite. I just want it to rotate around Y, right? So I'm going to lock rotation around X and Z. Let's see what else. Roscopic dark enabled. I think this is a good one to enable, if I recall correctly. And I definitely recommend you disable apply impulse and damage because with high impact is gonna apply impulse, which means it's gonna push the object back. Let me compile that. Hit play. Let's try it again. Okay, now it's not gonna leave the plane. Of course, it's rotating by itself because I don't have right left control yet. It's still kind of fun to play with. So next thing, actually there are two things which I think are good. Well, I won't do like you could create a physical material there and make sure it has no bounciness. But since I edited the ignore the apply impulse and damage is disabled, I think it's not necessary. Okay, well, let's try with rotation. If with rotation we get some weird results, I go back here. So yeah, let's go back here. And now what we want is to apply rotation. We didn't add the logic to apply rotation, which will be pretty simple to like, we're gonna get the rocket mesh component, which is the guy which takes the physics effect, because the actor itself doesn't, the component does. And we're gonna set, well, what actually makes it rotate, it's gonna be the add actor local rotation. But we should zero out the physics rotation every frame because remember that this guy is going to be called right when our D or A keys are pressed. We're going to add that to the tick check, and then we're going to call apply rotation. So, but anyways, what it's going to do is going to we're going to zero out the force. We're going to set the physics angular velocity in degrees or radians. That won't make a difference because what we want is to zero that out. And there's a shortcut. Of course, you could do f vector 0, 0, 0, and that's a zero length vector. Basically means okay, stop rotating, right? So we want to stop rotating, and then we apply the rotation. So it does not accumulate over multiple frames. Otherwise, you're going to be holding D and it's going to be, starts slow and then accumulates and starts whirling out of control. You don't want that. So you can do that. But there's a shortcut in the namespace f vector. So whenever it's a property or parameter or method of the class, you add double columns, right? And one of those options is the zero vector. It's just a shortcut. That's another trick, which makes coding, easier, shorter, and it's easy to read too. So just call the zero vector and that'll zero out the rotation. And now we will apply the actual rotation. You could do that. The torque is the recommended way. I just don't think it's digital enough. So I do the add actor local rotation. And by default, it takes a rotator. And what we want to set the angles for pitch, yaw, and roll. And we don't want any pitch, which is rotation around X. We want rotation around Y. Again, Y is the depth. We want it to rotate like that. So we gonna add the delta rotation here, right? So that creates a new rotator, which is applied to the local rotation. The only thing missing now is to add the check for the keys. Um, so let me create rotation force. So if it's basically the same, PC as input key down, but this time it's gonna be E keys A for rotation. And there are better ways to do that in a real engine, right? This is like a very crude way, but it's what we can do in the fastest way possible. So this we'll call the apply rotation with, and we're going to use the rotation force multiplied by delta time, which is basically the time that it took from the previous frame to this frame. So we do that to make it FPS independent. We explored this concept a lot during our course, of course. But basically, yeah, we're going to be applying that and make it at FPS independent. So if there's just one line, you can just remove the braces. That's another small trick. And so it makes your code a little bit shorter. And if it's D, you're going to do the same, but the rotation force will be negative. Actually, it could be like that, you know. Hmm. Yeah, I think that's the negative one. We'll see. That's one way you could do it. Or if you want, you can also, because apply rotation takes a float, as you can see by hovering the method. So you could just do the, I don't know, float rot, and for instance, this. And you know, you could just apply the negative here because, like I said, it's just a float. So you could just apply like rotation and here negative rotation. That's a little small optimization, the minor one, but it helps a little bit on the eyes that it just apply rotation with the rotation that calculated before. It could be positive or negative. If you want to make it even more visible, because sometimes the dash is kind of visible, you can do that if you want. Not necessary, but could make it a little bit more readable. So yeah, that's how we're forcing. Notice that we're forcing rotation in a physics object. So it's not always the most stable thing in the universe, but hopefully it'll work for our use case. Success, hit play. So now I can rotate. I think the rotation force is kind of, actually it's just applying to one direction. So I probably screwed up something here. Let's see. Um, rotation force time delta time. Not sure if I did the other way around. Let's see. Let's do this. Let me increase the rotation parameter. Oh, if you want to find your properties, just go to all, scroll to the bottom, and then scroll up a little bit. And you're gonna see the parameters here. Let me find that. Well, the actor can be damaged, as you can see. Mm. And where's the thrust force and rotation? Here's thrust force and rotation force. It's at the rocket section. Let me increase that to, I don't know, maybe 20,000. See if it makes a difference. Oh, you see how the two forces are literally fighting off each other. So let me lower that. And nothing stops you from applying rotation even at the ground to see what happens. This doesn't seem to be enough. Try 5,000. It's barely rotating for some reason. Hmm. Let's see. Let me just try mesh component. Yeah, I think set physics handler. I think there's an add angular impulse. Let's try that. I'm not sure if impulse is better. And the local rotation. Oh. Add actor local rotation, so I was using a radial force. Torque, I tried torque. It's pretty hard to get it working just as, although it is the recommended option, not usually the best one. Let's try angular impulse. I haven't played with that before. It's probably interesting. Let's see. Let's see what it gets us. Right match component, and that'll be a float. No, it's an F vector. The velocity changes 0. Okay, so let me just add this guy. Oh, no, not F rotator, F vector. Um, Z is up, Y is forward. Okay. Got a rotation is what gets in here. It's called by apply rotation. Okay. Let's see what gets us. Just not too crazy. Since I'm zeroing out the rotation speed, it's kind of tricky to get it really correct. You see, obviously, if you remove the zeroing out. Oh, by the way, I hadn't compiled that, I think. Let me compile it first. Okay. Yeah, it's zeroing out the force, so it's not adding up enough. So let me just get rid of this. Should get spinning out of control, I believe. Physics is always a bit tricky. There we go. Okay, succeeded. Yeah, it is spinning really fast now. Oh, and the bouncing, that's what I was talking about. It's just bouncing whenever it hits, really a lot. So new physics material would work for that. So it doesn't get any restitution when you rotate and you get in contact. But it's just I try a bit bigger value here. Yeah, also not a great idea. Try a lesser one because it's literally accumulating. So yeah, very hard to control it. Like so, try again. No, I don't like that effect, honestly. So let's see. That's correct. Add an angular impulse. Try another one. Set relative rotation. I think it's add relative rotation. And I need the rotator again. I forgot to comment this out. That was my mistake. Wait, let me do this. Do that right now. I revert. I copy that and just make sure. Yeah, you can't have both. That wasn't smart. Okay, I copied that line in case you need it. But you see how quick it is to iterate using the live coding? No, not good. I don't like that. Let me take that off and paste that again. Add relative rotation. Let's see. I think the numbers are coming in right. Let's see. One thing you can do, and it gets hard to debug, is use the UE log macro. It takes category. Usually you're gonna want the log temp warning. And here in the text, you just go for whatever you want to print. If it's just a text or if it's a variable. Um, like you can concatenate it. So here's just where how you would debug if it's getting to that point. And then you go to the output log here at the bottom, and you search for log one. So I don't see the message being printed, which tells me this guy probably is not being called. The apply rotation, float that rotation.
Did you recompile it?
I did, but
Oh,
I
okay.
think I forgot something here. Yeah, I did. I forgot the U property. It says not serializing. That's why. Yeah, not great. It's not U property, it's a U function actually. It shouldn't be needed to serialize, but maybe it's giving me errors with the compilation. I got out of live just to make sure. Let me just recompile it from scratch. Oh, it used the live compilation instead. Mhm. Yeah, you see, if assets reference the new or updated data types, it may cause packaging to fail because of the patching system. So that might be the culprit. Yeah, I see rotation adding forces now. So something did change. Rotation seems to be going to the wrong direction, but otherwise, it's a better option. So your function seems to be working now. Maybe function can be made constant. Nah, not needed. So let me try to and relative rotation. It's the same thing as that actor local rotation, but that's done to the actor, not to the component. So that might be my problem. Hmm. No, that's add actor. I cannot do add actor to component. Just add relative rotation. So yeah, either that or the torque. Let me revert the signals here because I think it's going in the wrong direction. Mhm. Yeah, still kind of weird. Seems like it's the friction. It's yeah. Let me add the materials. Trying to punt that, but it's just annoying. Materials, the create folder, and a new physics material. That's better. Go to physics or search for physics material, or go to physics and select physical material and inherit from physical material and do PM rocket. Now edit that and make sure you have restitution set to 0 so it doesn't bounce because of just contact. And override the combine mode so it's set to minimum so it never exceeds restitution 0, which is the bounciness. Uh, Friction is not that important. So just save it and assign that to the rocket. Better do that here. Physics material, where are you? Here, physics material override. You can just search for it here, PM. There you go. Compile save. Let's see if it gets any more behaved. It's just not rotating the direction that I want. Maybe, let's see. Let me see one thing here in a second. I'm rotating around Y. Yeah, around Y, that's correct. Delta rotation, F rotator, add relative rotation, add rotation. Same thing that I did in the other projects, just fighting me off for some reason. Let's see, a relative rotation. Mm, yeah. Well, it's just some minor thing that I'm not figuring out at the moment. Let's do this because we're basically over time. It's just check the other project to wrap the session up. But yeah, the next steps would be, if you go further with the project, is basically to check the contact here with the overlap and you'd have to edit this mesh because the mesh is given um, by default, it's given a very wide collision, as you can see. So you would add it there and add the new a new box collision there. So that when you try that, you check for the tag to see if you succeeded, and then you block the input. Pretty simple to do in C++ or in the blueprint system, whatever you prefer. And then you could assign the sounds, the Niagara particles, and start building up from there. But yeah, that's a pretty decent skeleton. Let me just open the test project and save everything up. And recent projects, the test. I should also put it here in this window. Mhm. Yeah, I set the physics angular velocity in degrees again to the delta rotation. You see, same logic. For some reason, it was just fighting me off in the other project. But yeah, see, I didn't set this one as default, so it just opened the old map. But I have the scenes here. Just for level one. It uses the very same logic. Of course, I had more time, so I worked more in the lighting, etc. But you can see that there's a little sound being played. Hold on a second. Hmm. The logic's not working. Or what? Oh yeah, I was plugging in the Niagara components. Let me just show you guys real quick the Niagara blueprint. Where's blueprint here? Print class. That's the one. And here in viewport, you can see that I can um, start, I think it's start active, something like that. The Niagara system. Start with tick enable. No, that's not. Uh, Niagara system. Here's where you assign the system in the position that it's placed here in viewport. And um, start tick enable. Scope or replicate. That's the active. Auto activate, that's the name. See, so when you toggle this on or off, you're going to have the thruster, which can be tied to the event of when you hold the spacebar. So if you want to know what effect I use, it's called perfect fire V effects. Okay. Um, all right, so I'm gonna wrap this up here because of time, but I hope you guys enjoyed it. There are definitely minor tidbits to tweak in terms of, the input system, rotation, etc. But the cool thing is that literally get a very flexible system where you can just play around and as soon as you do everything, wire things up properly, you get a really cool looking game with the lights, the way they reflect. It looks really good. So I hope it was useful. Let me check out any message that you guys left or questions. Hassan said, decided to finish the recording. TYK, I appreciate the overview. Thank you very much. Schedule full-time work, paid course similar to game dev. Sorry, I don't have any specific recommendation. You can check on Udemy, some courses there. Honestly, I haven't found many great courses in Udemy, but they were sensibly better than what I found in most YouTube channels. There are a couple YouTube channels which are good. I don't want to frame everything there as bad practices or whatnot, but there are plenty of um, uh, training videos which just try to hit the 20 minutes mark so they get properly monetized. So they just take too many shortcuts. Watch out for those, but there are some longer video tutorials. Check the official tutorials from Epic. They are good. They are way above the average of what you can find in YouTube, right? Um, and that's it. I hope you guys enjoyed. It
Oh,
was a pleasure.
I had one question,
Go
Breno,
on, go
if you
on.
don't mind.
Yeah, sure.
So you were talking about it earlier when you were showing the collision boxes for both those assets. And I was curious, did you convert the landing pad? Did you convert that to a complex collision box and just use
No,
that?
simple. A simple one.
Okay.
Yeah, you just go in here. Good question, actually. I would show that, but yeah, kind of run out of time. But yeah, just go to the Fab Sci-Fi Mobile Teleporter. Go to the static mesh. Open it. And when you get here, you get that weird, I don't know, weird shaped thing.
Right.
Just go to collision and remove collision. And then you add the simplified, use the box simplified collision. You can see it here with simple collision as long as there's one. You can edit the collision from here if you want. Just go to primitive boxes and you get the X extent, Z extent. It is kind of silly to be dragging those guys, but it's just, I could make it work without actually creating a blueprint out of it because all I needed was the tag, which is an actor element, right? So you don't need a blueprint to just set a tag and to set a collision. And the processing is done by the rockets to check for the overlap if you actually landed properly.
Okay,
Okay.
cool.
Nice. All right, guys. How complex is it to go from this to something like two Charlies? I wouldn't know. I guess it would take a lot more work. But that was a short session, and we couldn't wire up with UI. Everything they can do in Blueprints, you can do in C++. The main question is, should you? Because wiring boxes up is so simple. Obviously, when you're doing things in C++, you get one extra benefit, which I forgot to mention, which is better compatibility when you're migrating between major versions. What are major versions? For instance, Unreal Engine 4 to Unreal Engine 5. Some games which were over-reliant on blueprints they broke badly when migrating to Unreal 5. And devs just had to rewire things that for some projects made migration impossible. And for projects which relied way more in C++ and with just a thin layer of blueprint just to assign assets and stuff, it was way more smooth. So that's a side benefit of working in C++. And if you know the method calls and the function calls and blueprints, converting that to C++ like you saw with code completion, live compilation, etc., makes it quite affordable, right? So do not be scared to play with it. Like I've shown you guys, it's no seven-headed beast. So yeah, try, play with it, add your logs, apply the breakpoints systems in Rider is super powerful for you to track for bugs. It actually, when it's connected, properly connected, it literally pauses the editor, make sure it's connected here. I think it's development editor. Where is that again? Somewhere around here. Yeah, I think it got frozen. But anyways, there's a drop down here where you can just make sure you're connected to precise executable of Unreal, and it literally pauses the entire execution when it hits a snag in your C++ code, making debugging much, much easier. Okay, guys. Yeah, thank you very much. I hope you enjoyed, and I hope to see some of you guys in our next game developer programs. Back to later.
Yeah, thanks
Cheers.
again, Breno. Appreciate
Bye.
it.
Thank you very much. Bye.